So hello everybody, my name is Adrien Trauth. I'm a front-end engineer at Datadog. Our topic today is how to build advanced search experiences with a custom query language. First, I will focus on the use case. I will explain what a custom query language is and the benefits of introducing one in a search interface. Then we'll see how to implement it in the code of your advanced search. And finally, we'll cover different solutions to onboard your users, make sure they know where to get started and how to write their own queries. So let's get a bit more into the use case and why is an advanced search sometimes necessary and how can a custom query language improve the user experience. I'm spending most of my day working on our log management tool at Datadog, and doing log management is about allowing the user to search through millions of events and finding the right one. And so this gives us a few requirements for our search. First, since it's about troubleshooting, you're running a lot of different searches before you find the right information for you. So your search needs to be really efficient because you're running a lot of things and you're using the tool a very long time. Also, because you need to find the right logs that will explain to you what's happening inside your infrastructure. Your search has also to be very precise, because otherwise you will never find your needle in the haystack. And finally, since logs can be anything from system logs to database events to front-end logs, the format is not, the data structure is not known, and so you have to make your search flexible enough to be able to search through all those kind of different datas. So those are our requirements for the search. They're not really specific to log management, but that's the one we will be working with today. And let's see how common search interfaces match those requirements. So that's the basic keyword search you find on a lot of websites. It's really nice because it's simple. You can just get started in a few seconds. So it's really efficient. You type a few keywords, and in a few seconds you already have your first results. But the limitation with that keyword search is precision, because, for example, here, if I'm on a furniture store and looking for a blue chair, I have no way to tell the system that I'm not looking for either something that's blue or a chair, and I'm looking for a chair that's specifically blue. So you have no way to give the system what your intent is and to give the system more context about what you're searching for. So the way a lot of websites solve this is that they introduce an advanced search button, and when you click on that button, you will see a lot of different inputs and sliders and everything. And what this gives to you is a lot more precision, because every input has its own intent. So if I select the color blue, all my results are going to be blue this time. What you lose here with that pattern is efficiency, because you went from a search where you could type a few words and get results, to a search where you have to click around a lot and find out which inputs are relevant to you. And also it makes this a lot less readable, because you have to look, if you want to know exactly what you're searching for, you have to look at every input and the value of every input. And finally, it's not that flexible, because the way you set up your inputs will define the way users can search for something. So for example, here I put one price range, and if the user wants to search across two price ranges, he cannot do that. So, but as a developer, I actually know another way, another pattern to search for results, and that's query languages. So that's when you send, for example, to a database or to an API, some text that's going to return your results. The first query language that you usually learn about when you when you start, when you're a child, is natural language. That's asking a question in English. It's very flexible, because you can ask any question in English and it always will make sense. That's your own language. The issue with natural language is that it's not made for computers. So computers, they struggle with nuances. And also the range of questions you will be able to ask is a lot bigger than the question you can answer on your website. And so if you have Google or Facebook money, it may be fine, you may be able to solve that problem, but for your own tool on website, it's probably a bit overkill. The second query language that I encountered was SQL. So that's a query language for databases. It's very powerful because it allows you to query any kind of structured data. Also, it has great support, so you have a lot of databases supporting it, and if you would want to implement it, you would basically send the search through your server directly to the database. You have nothing more to do. But this is, for us, it's not really good for our use case because you have to know how the data is stored to be able to query it, and that's not something we want our users to care about. And it's a bit too complex, and it's not really what we want there. And so one other system that tries to solve this is GraphQL. Since it's an abstraction over data storage, it's a bit better because you don't have to care about how the data is stored. And what's really nice also is that you can define easily what kind of output you want for your data, but it's still very much targeted to APIs. So for example, if you see that query here, and you would, it's really nice if you want to send it over HTTP or if you write it in your code. But if you want a user to write that query, it's a bit long, it's a bit verbose. So that's not really what we want here. So since we've not been able to find any query language that match our requirements, another solution, since I'm a developer, is to make my own query language. I found a few examples of companies that actually did that. So on Jira, there is actually what they call GQL, which allows you to search through your tasks, through your issues. Prometheus, that's a monitoring tool. They also have their own way to create data. And at Datadog, what I found really funny is that there is another team that made their own query language to create data visualizations. And so we had two different teams finding the same way to solve similar problems. So what are the benefits of having your own custom query language? First, it's as high level as you want. So you are able to decide what you want your users to care about or not. So for example, if you want your user to be able to define the output format, like in GraphQL, you can include that in your language. But if you want to make it a bit more simple, you just remove that and do your own thing. It's also very specific to your use case, so you can make sure every word that the user types is relevant to your domain and to express what the user is looking for, and there is not anything technical getting in the way. And finally, since it's really a high level and use case specific, it's also very readable because the only words that are in the query are about your domain and not technical. So this seems to be a good solution for our use case here. So to be, and it's probably not perfect, but we'll get into the limitations a bit later. Now that I know that I want to make my own query language, I have to define it. And so a language definition is called a grammar. And so that's going to be the set of rules that define what a valid search is and the meaning of each word in my valid search. Two things you should care about when writing your grammar is that you have to make it flexible enough for the user to be able to write any kind of different queries. And also you want to make sure your most important concepts, the first thing the user is going to look for is the things that the first things they have to write so that they can benefit from your query language really fast. Let's give you a quick example to give you a better idea of what a grammar is. So that's my simplified English grammar. Obviously, we're not going to get into all the rules of English now. But if I were to define a grammar for English, my first rule would be a sentence is a set of words separated by spaces. And if I use that, if I use that rule, I'm going to be able to say, well, I have 3 words in this sentence, I, like, and meatballs. And then I can use a second rule, which would say the first word is the subject, the second word is the verb, and the third is the object, to say that, oh, I is my subject, like is my verb, and meatballs is my object. And so by defining all those kind of rules, you'll really be able to extract words and then the context of those words and find the meaning of the sentence. And know that we can apply that to my example, which is still a furniture store. And so if I were to write a grammar for my furniture store search language, I would be able to define a set of rules that say, for example, a search query for my furniture store would be a list of furnitures separated by spaces. So here I have 2 furnitures. And inside each furniture, there is first the type of the furniture, then brackets, and inside the brackets, there is a list of attributes I care about for those furniture. So by using that rule, I can say, here I'm looking for a chair and a couch, and the chair has the attributes blue, $100, and the couch has the attribute green. And if I want to go even further, I can say, well, actually, in my attributes, every attribute that starts with a hashtag will be a color, and every attribute that ends with a currency will be a price. So that's how you get into writing your own query grammar. And once you've defined all those rules, you can, once you define your grammar, the next step is actually to implement it in the code of your search. And so that's making the computer understand the search queries. So the goal here is to get from a string to an object that will be easier to handle in my code and will contain all the context that was extracted from the string. And then once I have an object that's really simple, I can use it anywhere in my, if I want to create databases, if I want to extract information for the user or anything like that. Once you have an object, you've pretty much done all the job. So to go from the string to the object is actually called parsing. And so parsing will say, well, actually from that query, I extract that one word is chair. And since I have some grammar rules, I'm going to be able to say, well, actually chair is not a color because it's the first word and it's not inside brackets. Actually chair is a furniture type. So that's what parsing is. And so the first thing I think about when I want to extract information from a string is to try with a regular expression. Regular expressions are really efficient when you're extracting information from emails or telephones. So when you know the number of things you want to extract from your query, it's really good. But when you don't know the number of things, your expression gets really complex. And also, it's hard to extract the context of the element you extracted. So it's easy to extract, for example, chair. But if I want to extract also that chair will be a furniture type, that's going to be a bit more complex doing with a regex. And I found this I think it's really good quote on Stack Overflow that says, if you write a regular expression, you go get a cup of coffee, then you come back and you have no idea what you just wrote, maybe a regular expression is not the tool for you. So I think that explains really why this is not good for our use case here. So the other solution to extract information from a string is to generate the parser from my language definition. From the grammar I just explained in English, I can actually generate a parser from that. And the way to do that is to write the grammar in another grammar. So there is actually a way to write grammars, and there are actually rules to write grammars. And so the one we'll be using today is PEG, with that's a parsing expression grammar, which is, I found one of the most readable ones. So how does that work in practice? Because it seems a bit hard now. So that's a grammar rule. So that's a grammar rule is made of first the name of the rule, and then your parsing expression. So your parsing expression will define the input you want to match and the output you want to return from that match. And so here for our furniture type rule, I'm matching a range of characters, repeating any number of times. And then I'm using that match result, which will be an array of characters, to return the full string of the furniture type. And so it looks a lot like a regular expression, right? Yes, but what's really nice with this way of writing different rules is that it's really easy to combine them. So here, for example, if I want to extract my simple character match, it's actually really easy. I just define a new rule and use that new rule in my furniture type rule. And what I think is really good about this is that it's really easy to reuse some kind of rules in the other ones. And also it makes your language definition a lot more readable, because here I can basically read that my furniture type will be a set of characters, and I don't have to care about like one kind of character, a lot of that or not. That's a different rule. So it allows you to write really complex rules in a really simple way. So another way to combine different rules is to put them in sequence. So here, if I want to define a price, I just need to define first what a number is, and then what a currency is. So number will be any integer, and currency would be euro, dollar, pound, anything you would want to. And from that sequence of character, my parser will try to match both. So if only one of them matches, it's just going to fail. And once I have matched both those rules, I'm going to be able to use both match results, which I call here amount and currency. And I will be able to combine both those match results actually in JavaScript. So that's inside the brackets, that's valid JavaScript. And to define a new match result for a price, which will be a combination of the two others. And a final way you can combine different rules is to put them separated by slashes. And then you will be, what that will do is that these are different options. So if I define an attribute as a price or a color, what the parser will do here is going to try to match price. And if that succeeds, I'm going to return the same match result as for the price. And if that fails, I'm going to go to the next one and try to match a color, and etc., etc. And once you have that way of writing different rules and to combine them in different ways, I can actually start defining my full query grammar for my furniture store. And here so I said in my grammar that I explained in English that a furniture will be a type, brackets, and any number of attributes. And what I think is really amazing here is that this is exactly what I'm reading in the code. So that's valid code. I actually wrote the full query grammar to make sure it's something that makes sense. And so here, if you read the first line in bold, it's defining what the furniture is, and I'm defining it as a furniture type, and then a list of attributes. And if I want to see what a list of attributes is, I can just go to the last line and see, well, a list of attributes is just one opening bracket, any number of attributes, and one closing bracket. And so what I love about this is that every rule is actually quite simple. And you can go from very simple rule to a full query language in a way that's really testable, really easy to improve on, really easy to extend, because that's code that's really readable and really simple. And once you've done that, once you have your full query language or your rules defined, you just have to run it through RegEx, and that's going to generate a parser you will be able to import in your code. So I'm just running it through in the command line, or you can just use it. There is also a pack loader if you want to make it automatic. And now that I've generated my parser, I'm just importing it, running my queries through it, and I'm going to be able to have the exact object I was looking for. So, and now that I'm able to parse my different queries, I can just use that in my search. Type chair, hashtag blue, and I'm going to only have a blue chair. So I used to have my keyword search, which would return either chairs or things that are blue. There was a blue table in the results. But know that my query language provides intent. Know that I can say, well, the color is applied to chair, and color blue is actually a color. I can implement it in my, it's matching actually all my requirements. So I have the intent, so that's precise. It's also efficient because I just have to a few keystrokes type to get results. It's readable because I have the full search in my query, and it's flexible because I can have any number of attributes, any number of furnitures. Flexible is actually up to you when you design your search language, so it's a balance to find. So did we do it? Did we solve the search problem forever? Well, not really, because having a custom query language comes with one big limitation, and that's user onboarding, because now that you have a language that's either valid or not, the first experience you can give to your user is that before they would type anything and that would always work. But now what they can do is that the first search they type is not valid, and you won't be able to parse it, and they won't get any results. And that's really frustrating for your users. So you need to teach them two things before they are able to write their own queries. And the first thing is the grammar. What is a valid query? And the first thing is a possible attribute. So you want to tell them, well, you can search for a chair, for a couch, for anything you want. So you need to tell them what kind of values they can put inside the valid queries. The first thing you need to do is add documentation. That's really important. You always need documentation. And to give quick access to the documentation. But that's not enough, because to make them want to go to the documentation, you need to give them a few valid searches so that they know that, oh, that's really useful. I want to learn more about that. And so one way that really worked for us is to have a help playground, which is kind of like an advanced search. So we're adding back some inputs, but the difference is this time you're not using the inputs to make queries to the backend. You're using inputs to modify the search bar and to add a valid search inside your search bar. So let's see how that would look. Yeah. So here I select chair, and it's adding chair to my queries, and then blue. And once you have a valid search, the user will be able to, by himself, to improve upon it and to start typing his own search queries. Because it's teaching by example, and that's really good. You want to give him, to show him what it looks like, and to show him, oh, it's actually really simple, I can do it myself now. It's progressive, because you start clicking around, and when you feel ready, you can start modifying your search. And then, if you feel like you're even more ready, you can, you can write your own search and hide actually the help playground. You cannot use it anymore. And it adapts to your user, because if they want to learn more about it, they can just type things. But if they never want to learn about it because they only come on your website once, well, they can just use the click the inputs and never care about the query language. It's really not an advanced search, because you don't need to click the checkbox anymore. So you can use them, but you can also be really efficient not using them. You don't need to put all your attributes. You can add some of them in the documentation. And also, since the state is synchronized with the search bar, you actually don't need to read the state of every select you put, so it's actually still very readable. And since I have a JavaScript parser, it's actually really easy to implement, because I already know how to extract information from my query to fill the selects. And the only thing I need to add is a way to, when I click, to add the value to my query and to print it again. And that's kind of easy to implement, because my object is simple, so I just need to push a value inside the object, and then to define a print function. And the print function is actually fairly straightforward, because all the context is in the object. So it's really easy to go from all the context back to a string. So here, for example, I say furniture will be a furniture name, and the print value of all the attributes. And for attributes, since in the attribute name it contains a lot of context too, I can say, well, if it's a color, you print it as an hashtag and the attribute value. So you have no way to generate this, but if you're writing it by yourself is actually fairly straightforward. So, and a few things you can add to for your onboarding is error reporting, so telling the user why his search query is not valid. Syntax highlight, if you want to have the most important information stand out, and autocomplete, which is really useful actually to showing what values they can type, so a set of colors or chair, couch, when they start typing the query. So autocomplete is really efficient. So the benefits of having a custom query language are it's efficient, it's precise, it's readable, and it's flexible. The drawback is that you have teaching your users become really crucial, and you have to care about that a lot more than with a simple keyword search. So a good use cases for a custom query language would be a tool that user use repeatedly. So if you have a tool that they spend a lot of time on, being efficient becomes a lot more important. Also sharing, because it's always nicer to share a small search that's readable than a full object or anything like that. And if you want to have integrations like APIs or integrate with other services, it's always nice for the developers to be able to type the query, copy paste it in their HTTP request, and that's just going to work. Thank you for listening. If you have any questions, sorry.